Let's now look at the one more example of the non-preemptive scheduling, priority non-preemptive scheduling. So given to us P1, P2, P3, P4, 4 processes with the arrival time, burst time and their priority. Okay. So now what we have to do here then? We have to draw the Gantt chart and we have to maintain the ready queue. So as the sum of the burst time of all these processes is 10. So 10 time slices I have drawn over here. So first by default we have the process P2, which comes into the ready queue. Process P2, it is a process with the arrival time 0. So by default ready queue will be as per the arrival time. So P2, it is the only one process. Okay. So you have to start the execution of process P2. Process P2 we have started. Then after every unit, now we are going to check whether any new process is there into the queue or not. Yes, at unit 1 process P1 comes, at unit 2 process P4 comes, and at unit 3 process P3 comes. So means when the execution of P2 is going on, so meanwhile process P1, P4, P3, this is the as per arrival order. So processes are coming into the ready queue, isn't it? So as it is non-preemptive approach, first of all process P2 will complete its execution. Once the execution of P2 has been done, now here we have to check out of these three processes which is the process with the highest priority. So we do have the process P3. Process P3 is having the priority as 1. So process P3 will continue the execution. We have selected process P3 with the burst time 1 and priority 1. Okay. So process P3 has done the execution. Now remaining processes are P1 and P4. So out of this, P1 is having the priority as 4 and P4 is having the priority as 2. So yes, we are going to select the process P4 with the priority 2. So having the burst time 3. So P4 will do the execution for 3 units. And then the remaining process is P1 with the burst time 2 and priority 4. So P1 has done the execution. So where every process has completed their execution, then only it would be possible for the remaining processes to start their execution due to the non-preemptive approach. So now just put up the values. So P1 with the finish time as 10, P2 with the finish time as 4, P3 process with the finish time as 5 and 8. So what is turnaround time? Finish time minus arrival time, that is, so here 4, here it is 2, here it is 6. For waiting time, turnaround time minus burst time, 7, 0, 1, 3. And already we have seen how to cross verify the answer, isn't it? So easily we can cross verify. P2 process comes into the ready queue at the unit 0. It has started the execution, so that's why waiting time is 0. Process P3 comes into the ready queue, process P1 comes into the ready queue at the time 1, but started the execution at time 8. So it was waiting for 8 minus 1, 7 unit. Process P4 comes into the ready queue at unit 2, but started the execution at unit 5. So 5 minus 2, 3. And process P3 comes into the ready queue at unit 3 and started the execution at unit 4. So waiting time was 1. Turnaround time is nothing but what, then sum of burst time plus waiting time. So it might be possible in case of non-preemptive approach of the priority scheduling, more than one processes come into the ready queue at the same time. If here in a ready queue we have two processes with the same arrival time but different priority, same arrival time, different priority, then we are going to select the process as per the priority, the process with the highest priority. But it might be a possible we can have a scenario where we have two processes with the same arrival time and with the same priority. Two processes with the same arrival time and same priority, then in that case to break a tie we can go for the FCFS approach. Which process is there first of all into the table, we can select that particular process. Okay, if I say here P2, P3 and P4, suppose they do have what, in the same priority and their arrival time is also same, so obviously we will pick up the process P3. Okay, just for simplicity, okay, because it is a process into the table at the start before P4. Okay, So this is all about the priority non-preemptive scheduling.